Welcome to the Central Soil and Materials Research Station, CSMRS, an office under the Ministry of Jal Shakti, located in New Delhi. What is the most fundamental necessity of life? It is water, the essence of existence, the foundation of development, and the heartbeat of civilization. Water conservation has been a necessity of the past, a demand of the present, and the hope of the future. To ensure the water and energy security of our nation, the stability of water resource structures becomes paramount. With this perspective, the Government of India established the Central Soil and Materials Research Station, CSMRS, in 1954 in New Delhi as the Soil and Materials Directorate of the Central Water Commission, CWC. Since its inception, CSMRS has served the nation through research, consultancy, and testing services for various water resource projects in the country and neighbouring countries. On the recommendation of the high-level committee constituted under the chairmanship of Dr. M.S. Swaminathan, CSMRS was separated from the Central Water Commission in 1981 and made an attached office under the Ministry of Jal Shakti, Department of Water Resources, River Development and Ganga Rejuvenation. The mission of CSMRS is to establish a world-class center of excellence in the fields of soil mechanics, rock mechanics, concrete technology, and water resources research and development. Its vision is to be responsive to changing global needs with an emphasis on quality, innovation, sustainability, and professional and human values, so as to make an effective contribution to public welfare and socio-economic development. The activities of CSMRS relate to research, testing, and consultancy, providing assistance to government departments and public sector undertakings. In addition, it also undertakes training, dissemination of information, and academic collaboration with universities and research institutions. The main areas of work include soil mechanics, rockfield technology, geosynthetics, soil dynamics, rock engineering, geotechnical instrumentation, concrete technology and chemistry, numerical modeling. The soil mechanics division focuses on the mechanical behavior and engineering properties of soil. Soil characteristics are identified through tests such as particle size analysis, liquid and plastic limit tests, and soil classification. The optimum moisture content and maximum dry density of the soil are determined by compaction tests, such as the automatic Proctor test. Soil compressibility is studied using automated consolidation equipment, which is essential for the stability analysis of dams and foundations. Digital servo-controlled triaxial tests are performed to determine shear strength. Field investigations include exploratory drilling, permeability tests, plate load tests, and standard penetration tests, SPT, which evaluate the behavior and bearing capacity of the soil on site. The geosynthetics division utilizes modern materials such as geotextiles, geomembranes, geocells, and geocomposites, which aid in seepage control, filtration, drainage, erosion control, and reinforcement. The rockfill division studies the strength and deformation characteristics of rockfill materials. Model materials are tested using relative density equipment and large-scale testing devices. This division also performs quality control and health monitoring in dam projects through on-site tests such as density measurements and permeability tests. The Geophysical Division is equipped with advanced instruments such as seismic refraction, MASW surveys, and cross-hole testing, which are used to determine P-wave and S-wave velocities. Resistivity imaging techniques are used to assess the properties of subsurface materials. This division also operates vibration monitoring equipment and remotely operated underwater vehicles, ROVs, for inspecting dam surfaces and underwater structures. The Rock Engineering Division conducts laboratory and field investigations of rocks and rock masses. These include uniaxial compressive strength, UCS, testing, triaxial compression, indirect tension, slake durability, point load, in situ stress measurements, uniaxial jacking, and direct shear tests are performed for underground structures. ensuring the stability and safety of dams. The Concrete Division conducts construction material surveys, aggregate testing, alkali aggregate reactivity testing, and concrete mix design. It also provides thermal studies of mass concrete and quality control and assurance services, such as for the Polavaram project. Non-destructive testing (NDT) equipment, such as rebound hammers, ultrasonic pulse velocity meters, and half-cell potentiometers are used to evaluate the structural integrity of concrete. The health assessment of the dam galleries are carried out with NDT equipments. The Chemistry Division analyzes the chemical properties of construction materials such as soil, water, cement, fly ash, and admixtures. Advanced instruments such as X-ray diff. The Workshop and Instrumentation Division manufactures precision instruments such as three-dimensional crack meters using advanced lathe and milling machines. These instruments are installed at various project sites for long-term performance monitoring. CSMRS also undertakes forensic investigations, contributing to studies on critical incidents such as the Gharra Dam, Tapovan Vishnugarh project, and Dharchula landslide in Uttarakhand. To promote knowledge sharing, CSMRS organizes annual training programs featuring expert lectures, laboratory sessions, and field demonstrations for engineers, researchers, and students.